So moving on to page 2 of surface area, we come across this slightly more complicated looking shape here. Just like we can with two-dimensional, three-dimensionally we can have composite shapes here too. When you deal with a composite shape in surface area, one of the tricks is to kind of think about what would I actually have to paint, what would be on the outside. It might be easier in some ways to list the parts and pieces you need than trying to just go right to formulas. Looking at this, for surface area, the parts on the outside, I see on the top we have 4 triangles, the parts that go around the outside, if you will. And we have our 4 rectangles, the bottom part, that go around the outside. And each of those is actually the same size too, right? So we got those 4. And then we have a square top, sorry, a square bottom. Okay? We don't actually have the top of the rectangular prism because it's inside the shape, this piece right in here. Same with the bottom of the pyramid, that piece is on the inside. It wouldn't really count towards surface area. It's buried inside, if you will. Okay, so then I can take a look at the formulas and think about two-dimensional shapes again. Okay, triangles. Right? Area of a triangle is base times height divided by 2. I'm going to need 4 of those. Rectangles, so I'm going to need 4 length times width. A square. Okay, that's my length squared. That makes my life a little bit easier. For my triangle, because we have that base and height, I need to think about, right angles. So my base and height meet at a right angle. So if I were to take one of these triangular pieces and break it apart, let's say I took this front one right here. Here's my triangle. Okay. If I redrew that, I don't really know the height of it. The height would be going this piece down here, right? That's my height. I know the bottom is 8, but I don't know the height, so I can't just go directly to my formula here. To find that height, I kind of need to think about a pyramid in terms of, again, I'm going to draw one more triangle here, down the side, down the middle, and out the side. Okay. This diagonal piece here is the height of the front red triangle. Okay. The vertical height in here would be a 3, because we know that from over here. If I were to draw that triangle out, okay, I know that's a 3. I know that's my diagonal height. And I know the bottom is coming out to the midpoint of this bigger shape has to be a 4. Well, that's a right angle triangle. Knowing this height here will allow me to find that height because they're the same. They're just looking at them from different viewpoints. To solve the h, I can use Pythagoras. 3 squared plus 4 squared equals h squared. In my calculator, that's 25. If I square root that, that's 5. So the height of each triangular face is 5. That allows me to go back to my formula for surface area down here at the bottom and work with 4 times the base. The base of each triangle we know is 8. The height of each triangle we just said was 5 divided by 2 plus 4 rectangles. Each rectangle measures 8 by 4. Rectangle is this shape right here, right? 8 across the bottom, 4 up the side. Plus my bottom, my square on the bottom is each 8 by 8, or in other words, 8 squared. If I do this in parts and pieces, I have 4. 8 times 5 divided by 2 will give me 20 of those. 4 times 8 times 4 is 128. And 8 squared is 64. And one more line, 80 plus the 128 plus the 64 will come out to a total of 272 meters squared. Okay, so even though it is a three-dimensional shape, I dealt with it as a series of two-dimensional shapes because it's a little bit easier to work with when I have a composite thing, in particular the parts that are on the outside. Okay, if we look at the second example, give it a try. Maybe draw a picture, see what you can do. If you're not sure, watch the video, of course, and if you are sure, check your answers, see if you got it right. Okay, we're looking at a candle in the shape of a cylinder. Okay, so we draw ourselves a cylinder here. Okay, we know the diameter is 3 inches. Okay, all the way across, it's 3 inches, which means our radius is half of that, so 1.5 inches. And they're telling us that the surface area is 70.7 inches, which is unfortunate because that means we're going to be solving something. They tell us the answer, usually means you have to find parts and pieces. They're asking us to find the height, part A. So height is this part down here, right? From here to here. Okay, the total surface area, so let's look at the surface area equation. Surface area is 2 pi r squared, 2 circles, top and bottom, plus 2 pi rh, the lateral surface, the part that wraps around the outside. What do we know? Let's fill in what we do know. We know our surface area is 70.7. I know 2, I know pi, I know r we figured out was 1.5 inches, it was half the diameter. 2 pi, r again, 1.5, and h I don't know, so let's leave it in h. Okay, I want to solve this. I want to use some algebra. So what can I do? Well, 70.7 is 70.7. I can't really do anything with that. But here, 2 times pi times 1.5 squared, I can multiply that all together and end up with 14.14. I can do the same thing over here, except there'll be an h attached to it. That comes out to 4.92h. Okay, it looks like a linear kind of equation. To solve these, we usually put numbers on one side and letters on the other. 70.7 is a number, so is 14.14. I'm going to cross the equal sign to the opposite operation. So 9.42 has an h attached to it, so it stays as a letter term. Okay. I can simplify this a little bit, make my life a little bit easier here. If I subtract these things, I'll end up with 56.56 equals 9.42h. To find h, I need to divide out that 9.42 bit on both sides. And my h, my height of my cylinder, turned out to be 6 inches. And so we can use a little bit of algebra to solve problems. Always fill in what you know and solve for what you're not so sure about. Okay, part B. The candle's burned down to half its height. Okay, so our height's now 3 inches, right? Will the surface area be halved? Well, I could think about this logically, or I could try the math. Okay, my surface area would be the same formula, 2 pi r squared plus 2 pi r h. Our radius hasn't changed, it's still 1.5. Radius hasn't changed here either. But they said the height is going to be halved. So it was 6, now it's 3, half of our original height. And we put that in our calculator here. I can do it all one time this time, all the parts and pieces. Comes up to 42.41 inches squared. So the question was, when we cut it in half the height, is the surface area half? Well, our surface area was 70.7, and now it's 42. Is half of 70.742? Obviously not. So no. Okay. Just because the surface area, the height is halved, does not mean the surface area is halved, which I'm hoping would make sense because surface area involves more than just height. It involves the radius of that object too. So we'd have to deal with both things if we want to deal with half of the surface area. Okay, and that takes us to page 3. One more example. Give it a try, read it over, see what you can do with it.